Good morning. Now we are going to learn about aim number 3. In aim number 2, we learned surface areas and volumes of the solids, different types of solids. Here also we will know about the surface areas and volumes of the different types of solids, but here we will know about the combined solids. Combined solids. That means if I taken these two solids, if we joined these two, then we will get one new type of solid here. So such type of solids, we will find the surface areas and volumes for these type of solids in this aim number 3. Now see the first one. A cone is mounted on a cylinder. A cone is mounted on a cylinder. So this is one cone. If it is mounted on this cylinder like this, then for this we have to find height and surface area and volume. First one is height. How to find the height of this solid? So here for this solid, height is height of cylindrical part and height of conical part. Both cylinder, cone, both if we add, then we will get the height of the such solid. So height of cylinder plus height of cone. Height of cylinder plus height of cone. Second one is surface area. To find the surface area of this solid, so we have to add surface areas of cone, cylinder, surface area, that means CSA, curved surface area of cone, curved surface area of cylinder, and base, that means area of the base of cylinder. If we add that three, we will get surface area of the newly formed solid. So write down CSA of cylinder, CSA of cylinder, CSA of cone, CSA of cylinder, CSA of cone plus base area of cylinder. CSA of cylinder plus CSA of cone plus base area of cylinder. Now third point, come to the volume. Volume is equal to, so to find the volume of this solid, we have to add the volume of cylindrical part, that means cylinder, and volume of cone. So volume is equal to volume of cylinder plus volume of cone. Volume of cylinder plus volume of cone. Now Second one also same for this some application, that is iron pillar, which is in the same shape iron pillar, but iron pillar is on the ground, so we want to take the base area. For the area we want to take the base area. So see that iron pillar. A cone is mounted on a cylinder, but it is iron pillar. So height is as it is same like previous. Height of cylinder plus height of cone. Height of cylinder plus height of cone. Next, second one, surface area. Surface area is equal to CSA of cylinder, plus CSA of cone. CSA of cylinder plus CSA of cone. Next, volume. Volume is equal to sum of the two solids. So add the volume of these two solids, we will get the total volume of new solid. Volume of cylinder plus volume of cone. So this is about the iron pillar. Now come to the third one. Now next solid is a cone mounted on a hemisphere. Next solid is a cone mounted on a hemisphere. So like this, if a cone is mounted on hemisphere, then height is height of the cone plus height of the sphere, that means radius of the hemisphere. Height is equal to height of cone plus height of hemisphere. So height of the newly formed solid is equal to height of cone plus height of, that means nothing but radius. Radius hemisphere. Okay, next, surface area. Next one is surface area. So to find the surface area of this solid, we have to take CSA of cone plus CSA of hemisphere. CSA of cone plus CSA of hemisphere. So if you add these two, CSA of cone and CSA of hemisphere, we will get the total surface area of that solid. Next, volume. To find the volume of this solid, we have to add the volumes of cone and volume of hemisphere. So volume is equal to volume of cone plus volume of hemisphere. So once again, see these three. Height is equal to height of the cone plus radius of the hemisphere, and surface area. Surface area is equal to CSA of cone plus CSA of hemisphere, and volume is equal to volume of cone plus volume of hemisphere. This is one of the solid. And next, now we will join three solids. Cylinder, hemisphere and cone. We will join a cylinder and a hemisphere and cone. Then for this new solid, we have to find height and a cylinder, hemisphere and cone. A cylinder, hemisphere and cone are joined. Now this is the newly formed solid. For that, first one, height. Height is equal to, observe the diagram, height of the cone plus height of the cylinder plus radius of the hemisphere. If you add these three, then we will get the total height of the new solid. So height of cone plus height of cylinder plus radius of the hemisphere. That is the height of the new solid. Next, second one, surface area. Surface area is equal to get the surface area of this new solid, we have to add CSA of cone and CSA of this cylinder and CSA of hemisphere. CSA of cone plus CSA of cylinder plus CSA of hemisphere. CSA of cone plus CSA of cylinder plus CSA of hemisphere. These three together form surface area of the new solid. And third one is volume. Volume is equal to, so to get the volume of this new solid, we have to add volume of cone, volume of cylinder, volume of hemisphere. If we add these three, then we'll get the total volume. Volume of cone plus volume of cylinder plus volume of hemisphere. Okay, so to get the height of this new solid, we have to add these three: height of cone, height of cylinder, radius of the hemisphere. And surface area is equal to CSA of cone, CSA of cylinder, CSA of hemisphere. And next, volume is equal to volume of cone plus volume of cylinder plus volume of hemisphere. Then next, now next solid, if two hemispheres stuck on both sides of the cylinder, that is like this. This is also called as a medicine capsule and a water tank also. Two hemispheres stuck on both sides of stuck on both sides of a cylinder. So this is also called as medicine capsule. Or water tank. So in problems they will ask like this also, medicine capsule and water tank. So if they ask like this, we have to use this type of solid formula. Okay, first one, height. Height is equal to, so to get the height of this solid, we have to add height of cylinder and this hemisphere radius and this hemisphere radius, because both of same radius, so we have to add the height of cylinder plus 2 into radius of hemisphere. Height of cylinder plus 2 into radius of hemisphere. Okay, height is equal to height of cylinder plus 2 into radius of hemisphere. And next, surface area. Surface area is equal to get the surface area of this solid, we have to add surface area, that means CSA of cylinder plus 2 into CSA of hemisphere. CSA of cylinder plus 2 into CSA of hemisphere. Okay, surface area is equal to CSA of cylinder plus 2 into CSA of hemisphere. Next, volume. Volume is equal to, so to get the volume of this solid, we have to add the volume of 3 solids, that means cylinder volume plus hemisphere volume plus hemisphere volume. Volume of cylinder, volume of cylinder plus 2 into volume of hemisphere. So volume of that solid is equal to volume of cylinder plus 2 into volume of hemisphere. So this is one solid. And next, next one is, if we joined 2 cubes, this type of 2 cubes, if we joined 1 to 1 together, then we will get a cuboid like this. We will get a cuboid like this. Then two cubes joined. If 2 cubes joined, then length of, if 2 cubes are joined, then we'll get the cuboid like this. So the length of that cuboid is equal to 2 into side of cube. 2 into side of cube. That means from here to here 1 square, 1 cube, and here to here 1 cube. So the length, total length will be the double of this side of that cube. Next, breadth. Breadth is as it is, same. Side of cube. Breadth equal to side of cube. And next, height is equal to side of cube. Height is also same, side of cube. Next, surface area. Surface area is equal to, so for example, for one cube, total surface area is 6a square. 1 cube, total surface area is 6a square. But if you joined 2 cubes, then one surface of the one cube and another surface of the another cube, both will be vanished. That means 2 surfaces will be vanished. So totally for 2 cubes 12a square, but 2 surfaces will be vanished there. So we will get total surface area as 10a square. That means 10 into side square. And volume is equal to 2 into volume of cube. 2 into volume of cube. So if you joined two cubes, then there will be new cuboid will be formed. That cuboid length is 2 into side of cube, breadth is side of cube, height is side of cube, and surface area equal to 10 into a square. Volume is equal to 2 into volume of the cube. Next, if you taken one right angle triangle, if you taken one right angle triangle, so this is the right angle, opposite to right angle this is the hypotenuse. So if we rotate this right angle triangle along with this hypotenuse, this is the hypotenuse. If we rotate this right angle triangle along with the hypotenuse, then like this we will get one double cone shape. One double cone shape, it will be rotated in this, it will be rotated along with the hypotenuse, then we will get double cone shape. Then for this cone, for this cone, what is the TSA and what is the volume? First one is height. Height of the cone, this double cone equal to, so here this is the hypotenuse of the triangle. So this is the height of the newly formed solid. So height equal to length of hypotenuse. So height is equal to length of hypotenuse. And next, surface area. Surface area is equal to, so to get the surface area for this figure, this is one cone and this side is another cone. So we have to add CSA of cone 1 and CSA of cone 2, then we will get the total surface area. So surface area is equal to CSA of cone 1 plus CSA of cone 1 plus CSA of cone 2. CSA of cone 1 plus CSA of cone 2. And next, volume. Volume is equal to, so here also there are two cones. So volume of that total figure, total solid is equal to volume of this cone and volume of this cone. So volume of cone 1 plus volume of cone 2. This is the volume of the newly formed solid. So once again see here, if you rotate one right angle triangle along its hypotenuse, then we will get like this some doubled cone. This side one cone and this is another cone. So for this, the height of that cone is length of hypotenuse. And next one, surface area is equal to surface area of this cone plus surface area of this cone. And volume is equal to volume of this cone and volume of this cone. Next one is a hemisphere. A hemisphere cut out from a cubical solid. So one of the face, this is one of the face. From this face we are cutting out one hemisphere. A hemisphere cut out from a face of cube. A hemisphere is cut out from a face of a cube. So if I taken this square cube from this one of the face, this is one of the face, from this we are cutting out one hemisphere. So total surface area is equal to, so except this face, remaining 5 surfaces will be there, and here we are cutting one hemisphere, then the circular part will be removed from the surface, and next hemispherical shape will be there. So total surface area is equal to TSA of cube plus CSA of hemisphere minus base area of hemisphere. So total surface area of this newly formed solid is TSA of cube plus CSA of hemisphere minus base area of hemisphere. Now next one is volume. Volume is equal to, so from this cube we are removing some part, so from the total volume we have to remove that part. That part is volume of the hemisphere. We are removing hemisphere, so we have to remove volume of hemisphere. So volume is equal to volume of cube minus volume of cube minus volume of hemisphere. So this is the volume of newly formed solid. Volume of cube minus volume of hemisphere. And next one is from a cylinder we are scooping two hemispheres from both sides. From a cylinder we are scooping two hemispheres on both sides. We are removing that parts. So that one is two hemispheres scooping from both ends of cylinder. Two hemispheres are scooping from both ends of cylinder. So then for this new solid, first one is total surface area. So if we are taking this cylinder only, so for this is the CSA, and we are scooping two hemispheres from top and bottom. So here there will be, actually for cylinder there will be circular face, but we are removing hemisphere, so then there will be hemispherical shape. So instead of adding base area, circular area, we have to add hemispherical area. So TSA, total surface area, is equal to curved surface area CSA of hemisphere plus this curved surface area of hemisphere and this one curved surface area of hemisphere. So total surface area of this new solid is equal to, total surface area of new solid is equal to CSA of cylinder plus CSA of cylinder plus, both are same hemispherical shapes, so 2 into CSA of hemisphere. Total surface area of that new solid is equal to CSA of cylinder plus 2 into CSA of hemisphere. Next, volume is equal to, so this is one cylinder, we are removing some part from here and from here, so volume of remaining solid is equal to volume of total cylinder minus these two volumes. So volume of that solid is equal to volume of cylinder minus volume of cylinder minus, we have to remove these two hemispheres, 2 into volume of hemisphere. So volume of newly formed that solid is equal to volume of cylinder minus 2 into volume of hemisphere. This is another type of solid. Now, next one is X spherical marbles. X spherical marbles are dropped into a beaker. X spherical marbles are dropped into a beaker, cylindrical beaker. Then the rise in water level. If X spherical marbles are dropped into a beaker, then the rise in water level is equal to volume of X marbles by base area of cylinder. So if X number of spherical marbles are dropped into some beaker, then the rise in water level is equal to volume of X marbles by base area of cylinder. This is one of the point. And the next one is, so if we converted one solid figure into another shape, one shape is converted into another shape, the volume is not changed. The volume will be same. If we changed shape, if we changed shape of solids, if we changed shape of solids, volume will be same. If we changed shape of solids, if we convert cube into cuboid or cube into some sphere like that, if you converted one shape to another shape, but volume will be same, there is no change in the volume. This is one of the another important point. And the last point is volume of masonry. Volume of masonry is equal to, volume of masonry is equal to area of cross section, area of cross section into its length. Okay, volume of masonry is equal to area of cross section into length. So here area of cross section is equal to area of cross section is equal to, area of cross section is equal to area of rectangle plus area of semicircle. So here volume of masonry is equal to area of cross section into length. To find the area of this cross section, that formula is area of cross section is equal to area of rectangle plus area of the semicircle. So these are the total formulae which are useful to find the surface areas and volumes for the combined solids. Now we will learn some of the examples. We will apply these formulae to the problems. Now I will explain some examples for this aim. First one, how many spherical balls can be made out from a cube? How many spherical balls can be made out from a cube of edge 44 centimeters? How many spherical balls can be made out from a cube of edge 44 centimeters? And each ball being 4 centimeters in diameter. So here we have to find the number of spherical balls, how many will possible to made from the given cube, which is a big cube. So here write first given data, given edge of cube, edge of cube equal to 44 centimeter. Then find the volume, volume of cube equal to, volume of the cube formula is a cube. So here that a value is 44. So 44 cube centimeter cube, 44 cube centimeter cube. Now this is the volume of the cube. And next, given diameter of the sphere, is equal to 4 centimeters. Given diameter of the sphere equal to 4 centimeters. Then find radius. Radius is equal to r equal to 4 by 2, that equal to 2 centimeters. So given that diameter is 4, from that we are finding radius. Radius equal to 2 centimeters. Then volume, volume of sphere, volume of sphere. The formula is, volume of the sphere formula is 4/3 pi r cube, 4/3 pi r cube. So in this substitute this r value, 4/3 pi 2 cube. So here by using this cube we are finding these all spheres. So we have to find how many number of that type of spheres will be possible. So number of spheres can be made, number of spheres can be made is equal to volume of cube by volume of sphere. Volume of cube by volume of sphere, that is equal to 44. Volume of cube is 44 cube. That means 44 into 44 into 44 by volume of sphere, 4/3 into pi, 22/7 into 2 cube, that means 8. Now simplify this, 44 into 44 into 44 into, take these values also to the numerator, we will get 3/4. 4/3 will becomes 3/4 into 7/22 into 8 will become 1/8. Now do the cancellations here, 22 ones, 22 twos. Next 4 ones, 4 11s. Next 8, 2 ones, 2 fours, 4 ones, 4 11s. So in the denominator there is no value. Now multiply the remaining values in the numerator. 11, 11, 3, 7. 11 11s are 121 and 3 7s are 21. 21 ones are 21, 21 twos are 42 and 2 44, 21 ones are 21, 4 25. That means 2541. So from the given cube, we have to made out 2541 spheres. This is one example for the aim number 3. Now one more example for this. A spherical ball of diameter a spherical ball of diameter 21 centimeters is melted and then recast. A spherical ball of diameter 21 centimeters is melted and then recasted into cubes. Recasted into cubes. Each of side 1 centimeter. Each of side 1 centimeter. Then find the number of cubes. Find the number of cubes can be formed. Solution. So here, once see the given problem, there is one big spherical ball of diameter 21 centimeters that is melted and recast into small cubes. So if you did that process, how many that cubes will be formed? We have to find that number of cubes. So first, here also we are converting one shape to another shape. So volume will be same. So volume of the cubes is equal to volume of that sphere. Both are same. Volume of the cubes equal to volume of that sphere. So first find the volume of sphere and next find volume of cube. Then find the number of spheres. So given diameter of sphere is equal to 21 centimeter. Then radius R is equal to 21 by 2 centimeter. Next, volume of sphere is equal to 4 by 3 pi r cube, that equal 4 by 3 pi r value 21 by 2 whole cube. Next, they given another one is also, that is side of cube. Side of cube A is equal to 1 centimeter. Then volume is equal to 1 cube, that equal to 1 centimeter cube. Now find number of cubes is equal to number of cubes is equal to volume of sphere by volume of cube, that is equal to, so volume of sphere is 4 by 3 by 21 by 2 cube. So 4 by 3 into pi value is 22 by 7. 4 by 3 pi value is 22 by 7 and 21 by 2 whole cube. Then 21 by 2 into 21 by 2 into 21 by 2 and by volume of cube. Volume of cube is here 1. So whole divided by 1, that is equal. Simplify this value, we will get the number of spheres can be made. So 4 2 ones, 2 twos. Next 2 ones, 2 ones. Next here 7 ones, 7 threes. 3 ones, 3 ones. Next there is another 2 ones, 2 11s. In the numerator there is no other value, so just multiply the numerator. 21 and 11. So 21 into 11. 11 ones are 11, 11 twos are 22 and 1, 23. And again there is another 21 into 21. 21 ones are 21. Next 21 threes are 63 and 2, 65. Next 21 twos are 42 and 6, 48. So 4851. So by using the given sphere, big sphere, we have to made 4851 small cubes. This is another example for this aim. So this is about the aim number 3.